So this one,
10 meters.
so she's moving, 5 meters per second?
Yeah.
So if you think about this, if it was you, just as like a conceptual idea, if you were running, someone throws a ball towards you, versus if you're running and someone throws a ball from behind you, which one's gonna hurt more when it hits you?
The one throw it towards you.
Right. Because,
Because the speed, like you're going forward, that falls. So the speed clashes and it makes it.
yeah. So this one is going faster relative to her.
Yeah.
It's kind of like too, if the difference between like a car going 35 miles an hour and hitting a brick wall versus a car going 35 miles an hour and hitting another car that's going 35 miles an hour. So if you have like this situation where you've got a car that's going 35 and it hits another car going 35,
That adds up.
yeah, it adds up, ends up being 70 miles an hour. That's a huge difference than if you have another car that's going, say, 40 and bumps the back of this car. So like if you're going down the freeway and you're going 75 and someone else is going 78 and they bump into the back of your car, it's a pretty big deal because you're going fast, but it's not gonna do a lot of damage. Versus if you are on the freeway, or versus if you're just driving down the highway going like 35, and somebody comes and hits you going 35 the other way, it's gonna total your car. So the reason for, well, I think it goes into the reason, but yeah, so this one will be going faster relative to her.
That works. Okay.
Yeah, you picked up that. So the relative motion equation is, let me think, how does this work? It's velocity of B with respect to A. So this is B, this is A. It's equal to, you take the first one. Yeah, so you take the first one, so B, and you'd say the velocity is negative 10 meters per second. And then you subtract the first one. So that'd be her, which is 5 meters per second. So the velocity of B with respect to A is negative 15 meters per second. That's what you did. So on this one, what would the velocity be? Let's call this one C.
So would that be positive 10 meters per second?
Yep.
Minus 5 meters per second.
So then you see that this one's only 5 meters per second. So it'll still hit her, but it's only going 5 meters per second relative to her.
Right. Okay.
Then the next one says, compared to her, both are moving at 10 meters per second. And relative to the ground, she's moving at 5 meters per second. So then which one is thrown faster? Which one is actually moving faster relative to the ground?
They're the same.
Well, so what it's saying is that, so on the last one, we found out that relative to her, if we pretended that she was standing still, the first ball would be moving this way at 15 meters per second,
Oh, okay.
and the other one would be moving this way at 5.
All right.
So that's kind of the situation. It's saying pretend she's standing still, even though she is moving to the right at 5 meters per second. Which one of these is moving faster relative to the ground?
2, pull 2. So that one on the right.
This one. So I guess this is saying, let's look at it for a minute. So this, let's call this B again. Now let's see. So the velocity of B with respect to A is 10 meters per second.
Okay.
So it's saying it's moving 10 meters per second relative to her motion. So then you say 10 meters per second equals the velocity of B minus velocity of A. Oh, -10.
Oh, so that's gonna be like -15, that was like, I mean, just 5, right?
Yeah, so this one would be -5 meters per second, because she's moving at 5 meters per second.
Right. So that's gonna add to -15.
We'll add this, and it'll be -5. So you just take this, you add 5 to this side. Those cancel, and you add 5 on this side.
-5.
Yeah, so this one's moving at -5 meters per second. Is how fast it was thrown. And then this one, velocity of C with respect to A equals 10 meters per second. Positive. So that means 10 meters per second equals velocity of C minus wait a minute. Did I do that right?
Yeah, 'cause I'm confused on this.
Sorry, I think I screwed that up.
Like, do we, because that ball's moving towards her, she's running that way. And before we got -15.
Right. So the difference is this time we're looking at it
From the ground.
with respect to her.
Okay.
So this isn't the speed of the ball according to the ground. This is the speed of the ball relative to her.
Oh, the 10 meters per second is?
Mhm.
Okay.
So that's saying this ball is moving towards her at 10 meters per second.
Okay.
But in reality, what's happening is, in reality, what's happening is she's moving at 5 meters per second. And this ball is also moving 5 meters per second.